Hi, my name's Emma Humber. I've worked in IBM's customer support in various messaging products for the past 10 years. Past few years, I've been focusing on Kafka, and I run the support for IBM's Kafka offering. And I'm going to talk through some of the things I've learned over the past few years about how to debug applications with a particular focus on Java. I'm going to hand over to my colleague, Tina, and she's going to talk to you about some of the things she's learned from her time in the event streams on cloud offering, where she developed some new features, and she's going to talk about some of the day-to-day operations she looks at and how metrics can be used to sort out your Kafka system when things go wrong. So where do you start? You want to be prepared. So you don't want to go to an outage or a failure blind. You want to prepare and know the sort of thing that you need to look for when things go wrong. You also have the chance to predict and mitigate when things start to go wrong. So you can see certain behaviors in your system and act when they happen. You want to ensure that you've got the right information available when it does go wrong so that you can understand what you need to do. So you've got an idea of what to do to fix it, and then you can prevent that happening a second time. One of the things you want to do to prepare is know what your system looks like. So when I've been working in customer support, one of the key things that we always ask people right at the beginning of a complicated problem is for a picture of the system. So understand what the flow looks like. So draw a picture of your environment. So the topic names, the host names, the node names that the brokers live on. Draw arrows. So draw your clients and how they connect in, interactions with the external systems. And this can be slightly tricky to do, actually, because it might be different departments that all need to come together to prepare this. So it's worth having it ready in advance. Kafka produces lots of data, and actually the environment that it runs in produces lots of data as well. There are logs from Kafka, there's logs from your applications, there's OS logs, there's OS metrics, there's disk usage, all that kind of stuff. So familiarize yourself with what your environment looks like before it goes wrong, and know what a working system looks like. So that you're not scrabbling around and going, should that log line look like that? Should it do that? When things go wrong, and you can focus and target the actual problem rather than the sort of the red herrings and the sidetrackings. Make sure your application logs as well. It's not just your Kafka environment here. There are clients that are connecting to it. I'm going to talk a little bit later about what makes a good log, but don't forget that there's at least two parts to the system. You need to make sure that they all give you the information that you need from them. When you're making changes, change one thing at a time. So if you've got a working system and you need to apply an OS patch, just do that. Don't do an OS patch and a Kafka patch and a configuration change. And one of the key things that I always ask is what changed, and keep a change history so that you know exactly what has changed in your production system, so that when something stops working the way you expect it to, you can start eliminating the various parameters and understanding at what point it broke. So you've prepared, you've got everything ready, but you need to then have a plan for what happens when things go wrong. And again, if you're prepared and understand the sort of things that you need to get ready, that puts you in a much better position for diagnosing problems and getting a quick resolution. So the first thing I always do is create a timeline. I've looked at many, many problems and bugs and outages, and I get my pen and paper out and I write, this happened at this time, then this happened, then this time. And where Kafka is a distributed system, this is particularly useful because it's not a single place that you're looking at. You need to draw together 6, 7, 8 different log locations and timelines and get a picture from lots of different places. And you need to interleave all those different things to get a clear understanding of what's happened and when and in what order. In each of the individual logs, I tend to look at the beginning for exceptions and errors. That's as good a starting place as any if you're not sure what's gone wrong, if things have just stopped working. But I also look for keywords. So there are certain phrases that I search for in the logs to understand if things have gone wrong. So the word goodbye in the Zookeeper logs is a real good indicator that you've got connection problems between components. ISR, so the in-sync replicas changing for your Kafka log. That's another good string to search for. Fsync is one of my key ones. So you can get an understanding of if your disks are running very slowly by the word fsync coming out in your Zookeeper logs. And another one that I've used a lot recently is looking for the Zookeeper connection string. So in our case, it's localhost because we go via proxy. But you can see every time your Kafka tries to reconnect to Zookeeper, it might loop round and round and round because it can't make that connection. You get a particular string that comes out. So become familiar with the sort of things to look for in a problem situation, and you'll be able to get to sort of the key bones of what is happening much, much quicker. One of the other things that I find particularly useful is to have a working system to compare with. And there's two reasons for that. When you are setting up your environments, you want a pre-prod system that's just like your production environment. The number of times I've seen customers, they've got a prod system that's kind of like their production environment, and they just don't see the problems in pre-prod that happen in prod when they start putting load through, or there's backups happening, or there's a virus scan kicks in and that interrupts the amount of CPU that's available for processing. So make sure your pre-prod environment looks just like production. Make sure you load test it so that the same sort of load is going through pre-prod as it is through prod. Have the same backups running at the same sort of time so you know the impact of those. And it's also a good place to verify your changes. So that's kind of the preparation side, but actually having an environment that looks just like production is really useful for a comparison and understanding when things aren't quite working. So a couple of examples of this are cases where we've had problems with the network setup. So we had an F5 load balancer that we saw that was letting traffic in on all the Kafka ports, but one of those wasn't letting traffic out again. And that was really hard to work out what was going on, but having a system to compare with, and we could compare what the F5 configuration was between the two boxes, made it sort of gave us a clue as to how to work out what was going wrong there. Another system, we've had reverse DNS lookups not working very well and or not being configured properly. And again, being able to compare with a working system made debugging that much quicker. So it's really useful to have a pre-prod system that looks just like your prod one that you can then go to and refer to when things aren't working quite right. When you do have an outage, often the focus is on recovering. So if you're running in Kubernetes, very often restarting a container or a pod will recover your system. But if you do that, if you delete a pod, it will delete your logs. So make sure that you've got a plan on what logs to collect when you have an outage so that you can grab those. You don't have to spend the time analyzing it at the time. You can get a general idea of what's wrong and see if a restart of the broker will help. But you need to make sure that you've got the data so that you can go back and look at what caused that problem, what caused that outage, because I can guarantee that if it's happened once, it'll happen again. There's a danger that actually you won't be able to work out what happened from the logs that you've collected the first time round. You might put in place your log grabbing plan, but it doesn't give you enough data. So if that happens, you need to take a look at what to do next time. So increase the amount of debug that's coming out your broker, add some extra metrics to collect. And it might take you several iterations to get to root cause. But each time you will learn what data you're missing and put in place extra things to get that information. So you've got the flow of what happened. You've got the flow of your system. You've got the timeline of what happened. You started working out isolating the component where the problem might be happening. But one of the things I learned in support is ask what changed. And the number of times that customers say, no, nothing has changed. The system's exactly the same as it was before. Is quite surprising. And very often you dig through and actually it turns out that there was a change in the system. So this goes back to the thing I mentioned in preparing. Keep a change log, understand what is new in your system, whether that's more load, but it's worth considering even if you think nothing has changed in your system. So when you start reviewing, there are certain things about a log line that make it much easier to understand and parse and work out what's going wrong. The Kafka logs do a good number of these things. So I'll talk through the sort of things that you get in a Kafka log, but consider which of these you need for your client applications too, and which are useful so that you've got logging at that side too. It's sort of your responsibility to make sure your client application logs sufficiently. So timestamps and a date at the beginning of the line. When you're scanning through logs, you don't want your eyes to be flicking back and forth looking for the timestamp to see when things happen, and especially when you're correlating things between different pods, different containers. Having the timestamp at the beginning makes it much easier to flick through and match those things up. Put a date in. I've seen logs where you've just got a timestamp and you don't know whether your error happened yesterday or a week ago. So remember the dates. Make the log line unique so that you can track down where in the code base it has come from. That might be entry exit points. It might be the class name and method name, but just make sure you know where it's come from. Otherwise, you're going to have to infer which bit of your code that's come from. Thread IDs are useful if you've got a multi-threaded application. I like logs to have configurable levels. So info level gives you enough to give a good guess of what's happening. But you want to have debug and potentially even very, very detailed trace for detailed problems. Make sure that your logs aren't so verbose that they're useless. So I work in a number of environments where logs are wrapped after 48 hours. And if your components write more logs than will be available after 48 hours, you're not going to know what's happened on a Friday evening when you come in on Monday. So just make sure they're not so verbose that they're not usable. So Kafka is configured using log4j. You can say where it logs to, you can say which packages to log out, you can say the log level. Java clients use the same log4j, so you can grab the Kafka log4j.properties and configure it for your clients. One thing to note for the Kafka packages is Kafka by default logs to one place, but the default configuration file lets you split that down per component, and you might want to consider splitting out your controller logs and your state change logs, for example, into different log files, so it's a little bit easier to see what's going on. Okay, so Kafka runs in a JVM. It's a Java application. Java's got loads and loads of tools for debugging problems, and make the most of these when you see a problem with your Kafka brokers. So I'm just going to talk through a few different ways that Kafka can break, and the JVM can be used to debug these. The first of these is a hang. So a hang or a deadlock, you've got one thread waiting for a lock held by a second thread, but the second thread is waiting for a lock held by the first thread. And neither of those threads can progress because they're waiting on each other. The obvious symptom is things just stop, but it's actually likely to be more subtle than this, especially if you're running in a Kubernetes environment. So one example I look back to is we had a deadlock in the metrics collection around garbage collection in the JVM. And the JVM just stopped. The garbage collection logs just stopped. The logging from Kafka just stopped. But the symptom was that the container got restarted because the JVM had stopped. It couldn't respond to the liveness probe. So Kubernetes restarted the container. And the logs just ended abruptly. So it wasn't obvious that processing had stopped because the environment recovered. So just be aware that a hang or a deadlock might not be quite as obviously a hang or a deadlock as you might expect. The other challenge if you're running in a Kubernetes environment is that your liveness probe might kick in. So it's difficult to see what's actually happening. So what you can do is either delete the liveness probe completely or just set it to very large values. And that lets the container hang around after the restart, after it would have restarted previously. So you can exec in and take a look. And what you would generally do if you suspect a deadlock is take some Java calls at intervals. So maybe 3 Java calls at 1 minute intervals. And you can use the kill -3 of the PID, or in OpenJDK, you can use the JStat command to collect those. So when you collect a Java call, it'll look something like this, or this is a tiny, tiny part of one. And what you're looking for is things that haven't changed. So the stack that looks the same. The stack looks the same here, actually, apart from the actual references that it's waiting on. So if you're doing I/O, the reading in from the sockets or the reading in from the file system is likely to be slower than your application processing. So the stacks will look the same, but the actual objects that are referenced will change if you haven't got a deadlock. If there's no change at all, it's likely that you do have a deadlock. So another thing you can get with JVMs is memory problems. So you can get out of memory exceptions written to the logs, you can get Java calls written. And there are sort of 2 categories for these. Either your JVM isn't configured with sufficient resources for the workload that you're putting in and you blow your heap, or you've got a memory leak. So to see what's using up the resources, you tend to get Java calls by default, but that's not really sufficient to understand what's going wrong. It'll give you an idea of how much memory is in use as demonstrated in the slide here, but it won't tell you what objects are using that. So you either need a heap dump or a core dump. These may not come out by default, so you need to make sure your JVM is configured to collect them. The other thing is that they may be lost on the restart of a container. So consider having a persistent volume to write them to if you're running Kubernetes so you don't lose them. You can use something like IBM's Health Center if you're using an IBM JVM to look at those as well. And that's a nice tool to understand what objects are using up the resources. The other kind of memory problem is Kubernetes based. So people quite often get mixed up here. They think if they see a 137 out of memory killed in the termination state in Kubernetes, that is because the JVM is hitting out of memory. Actually, it's because either the container is stamping over its allocated resources, or it's because the node is under resource contention and resource constraints, and Kubernetes is starting to kill containers and pods in an effort to kind of get some resources back. So one of the things to remember here is just make sure that you've allowed enough space in your resource requirements for your container to make space for the heap, and then actually allow enough space for the native memory and the page cache space above that. Otherwise, you'll get these 137 restarts. Kafka can be quite sensitive to garbage collection. So if you're seeing unexplained delays in processing or latency or gaps in timestamps in the logs that you wouldn't normally expect, take a look at your garbage collection logs and just look for lots of garbage collection or delays happening there. So what we do is we actually monitor quite a lot of JVM metrics. There's an example of some of them here. So we take a look at how frequently the garbage collection happens. There's a JVM metric that can be taken that looks for deadlocked thread counts. That's the bottom right one. And we also look for heap usage in the JVM and non-heap usage. And we just keep an eye on those, and they're a good indicator that things are starting to go wrong. So Zookeeper is another key component of your Kafka environment. And there are a number of diagnostic tools that are available for that. So it logs like Kafka. It's based on Log4j. There's various levels of logging that you can get out of Zookeeper. But there's a couple of other things that are interesting. So there's the four-letter word commands. So things like SRVR and MNTR that you can send to Zookeeper, and they respond with information about the current Zookeeper states. So, for example, the SRVR one returns the number of connections. It says whether that particular Zookeeper is a follower or a leader. And it gives you indications about the latency when talking to that Zookeeper. Monitor adds in, say, the IP address of the connected clients as well. And I found both of those commands quite useful when trying to understand strange behavior around Zookeeper. The other thing that's useful is the ZK CLI clients that lets you navigate around the Zookeeper tree. And one of the particularly useful things around that is if your replication has stopped. Because you can go and delete the controller ID in the Zookeeper tree, and that will prompt a re-election of the controller without actually having to restart any of your brokers. Okay, so I'm going to hand over to Tina now, who's going to talk about monitoring and metrics.
Right, so we've been running Kafka in the cloud since 2015 and gained valuable experience in monitoring Kafka environments. And so I'll be sharing what we learned in the past 5 years and what are the most important metrics to monitor, and some of the best practices in monitoring as well. So why is it important to monitor your Kafka environment? First of all, well, it can help you to predict some of these problems that Emma was talking about and identify abnormal pattern in behavior. It also provides historical data leading up to the time when the problem happened, which helps with debugging a Kafka issue. Right, so this is how we do monitoring at high level. So Kafka and the JVM, it runs in emit JVM Metrics, and which shows the point in time data for various kind of statistics. And you can use your choice of tools to scrape that data, but we use Prometheus to do that. And we also have Grafana querying that data from Prometheus and plotting them in nice graphs so you can visualize them. We also use some of these metrics to trigger alerts. And also we have an application running outside of a network. It's always a very good idea to do that, to test your external connections and also making sure your brokers are available. We get often asked by customers what metrics to collect and how can they tell if something is wrong with from these metrics. And there are tons of metrics available in Kafka, and it could be absolutely overwhelming, especially if you are new to monitoring. So what we usually suggest is start with a small set of metrics and give yourself time to learn and understand the trend, because every application behavior or system behavior is quite different. So you need to understand what's normal in a working system, and then you can spot when something is not right. And you can use some of these metrics to trigger alerts. So we usually have 2 tiers of alerts, warning for non-critical issues, and we have page alerts for any potential outage, which will call out our on-call engineers at any time. So especially with the page alerts, you've got to be really, really careful when you select metrics to alert on. There are a few bad behaviors you want to avoid. So having alerts that are false most of the time. So of course, you don't want to be waking up somebody in the middle of the night for alerts that are false. And having too many alerts going off, that makes it hard to know where the problem is. And also having alerts that are not well understood and not having any clear actions. And I know it's not easy to have clear actions on all of your alerts. So what we usually do is when we add in new alerts, we add it as a warning, and we spend some time analyzing it, analyze how noisy it is, whether it needs further tuning. And we also go about learning how to investigate that kind of problem and how to resolve the issue. And once we are 100% confident with the warning alerts, then we can change it to page. Also, after you have a problem or outage, go back and analyze what shape of data your existing metrics showed. You can always find if there's any other metrics that you could have had that could help you with this problem. And that way you can keep refining your monitoring. Or you might find some of your existing metrics could have helped you to discover the problem ahead of the time. So maybe you can use that as an alert. But you got to be very careful when you, again, avoid the bad practices. Also, watch out for not metrics. So make sure you're monitoring your monitoring tools. If they're not emitting any metrics, you can potentially miss out any problem that's happening in your Kafka system. So you don't want to be only monitoring your Kafka system. You also want to monitor your underlying platform. You want to be monitoring these things because they are directly have an impact on the health and performance of your Kafka system. And the network, slow network and insufficient bandwidth will throttle your throughput. So it's very important to monitor your network traffic. And one nice thing about network traffic is that you get to see the full picture of how much traffic going in and out of your cluster. This is because when you're monitoring the throughput just from the brokers, it doesn't give you the full picture because there are certain producer and consumer operation data that also takes network. And with the memory, we actually found monitoring the memory allocation and the garbage collection more useful than the actual memory usage, because with the memory usage, it keeps increasing and the garbage collection run, and then you will see a drop in the graph. And that is very hard to tell if you are being memory constrained, whereas if you monitoring the garbage, how often garbage collection is running, and if it's running very frequently, that's usually an indication of memory being constrained. And insufficient memory could lead to unexpected behavior. And of course, you want to also monitor your disk capacity and latency. You probably want to set a threshold and set an alert on this as well, because full disk will stop your data flowing in, and the latency will cause all sorts of delays. And generally, system running at the edge of its limit were more likely to fail. So you make sure monitoring all of this and then setting alerts, and then so you discover these problems ahead of the time. Right, so I talked about some OS level metrics, so I'm going to move on to a few key broker metrics. So as you already know, partitions are replicated across your clusters to improve the resiliency. So it's very important to know your partitions are in a fully replicated state. So their under-replicated partition metric comes quite handy in that. It's very important metric to monitor. But you probably don't want to alert on this metric. There's very interesting talk given by Todd Paulina, why you shouldn't be alerting in this metric, so you can check that out. The reason is partitions can go in and out of fully replicated state quite regularly because brokers are restarting, or you're running an update in your cluster, or garbage collection running. So it can happen quite often. So you don't want to be alerting and creating too much noise in your system. But we do have 2 warning alerts on under-replicated partitions if the partitions are not catching up for a long period of time, or the number of under-replicated partitions just keeps increasing. Also, if the replica number is falling under the minimum in-sync replica, so you definitely want to be monitoring this metric, and you probably want to alert in this metric as well, because it has an impact on your producers with Axel. producers with Axel, they won't be able to produce successfully. And also it has an impact on you consumers, because consumers also produce messages to consumer offset topic as well. And another important metric will be offline partitions. That means none of the replica of your partitions is available. So none of your clients are going to be able to send message to these partitions. So you definitely want to be alerting on this metric as well. Right, throughput. So this is how much data being sent and received by the producer and consumer applications. You'll be able to see how busy your cluster is. And you can also trend over time on these metrics on your overall throughput, which can help you to determine whether you need to expand your cluster. It shows overall performance and health of your cluster. So it will also help you to spot few problems. So if you see unexpected drop in the traffic, that's an indication of something is not right with the brokers or with the client applications. Or if you see one of the brokers way busier than the other ones with traffic, that's usually an indication of unbalanced traffic. Another useful metric to monitor for the unbalanced traffic would be the leader count, which gives you the number of partition leaders that are on the brokers. So usually a balanced traffic would have fairly even numbers of leader counts on those. Also, replication throughput is very important to monitor. And if your application is slow or stuck, you will be able to spot that kind of problems from it. Right, so those were the broker metrics. So some of the client metrics, as I said, as I mentioned previously, it's very important to monitor your producer and consumer applications. So if you're running client application, it's generally very important to monitor client metrics that's coming out of your Kafka clients. They also produce loads of different kind of metrics. So with the producer, these are the metrics that will help you to monitor the trend of the flow rates and the latency. So you'll be able to tell whether your message is being sent successfully, how quickly they're being sent. So especially with the record error rate, that's a very interesting metric. You probably want to alert on it, because that means your producer is exhausted all of its retries and failed to send a message. And the request rate, request latency, if you see a spike on these metrics, that usually an indication of a network or connectivity to your brokers. And the response rate is how quickly the brokers are responding to your brokers. So the most important metric is probably to monitor for consumers is the consumer lag. So you want to make sure your consumers are catching up and working efficiently. So there's a few metrics you can monitor for that. So records lag is the last consumed, the difference between the last consumed message and the last produced message. And you want to also set a threshold, and probably want to maybe alert on that. It depends on what's the acceptable lag in your situation. So for example, if you are consuming real-time data, you probably don't want consumers lagging too much behind. And the records lead mean, that's the difference between the beginning of the log and the last consumed message. So you want to make sure your consumer is not lagging way too behind and getting close to the beginning of the log, because you can potentially run into a problem where your consumer is trying to consume a message that's been already deleted. So basically, you want your records lag to be as small as possible, but you want to make sure records lead mean is as big as possible. And again, records consumed rate. So you want to see if you see a spike on the consumed rate, so that could potentially tell you that your consumer might fall behind. And then there's with the consumer tools, you can also there's the Kafka console consumer tool. You can get more information to debug more information about the consumer lag. Another important thing to watch out for consumer is the consumer rebalance. So if a consumer loses connection to the coordinated broker, and in that case, that consumer will be taken out of the consumer group and all its assigned partitions will be reassigned to the other consumers. And that is a stop the world operation. That means none of your consumer can consume a message during that time. So you want to make sure that rebalance, how often that rebalance is happening and how long these rebalances are taking. So we were recently helping one of our customer with a problem where the consumer was just constantly lagging. Their Kafka environment looked completely healthy and their cluster wasn't even that busy. And it took us a while to determine what the problem was. It was a problem with the customer application itself where there's a message process was taking longer than it should. So with Kafka Client Metrics, it's quite hard to determine where the problem is, if there is a problem with the application itself. And which is why it's quite a good idea to instrument your own application to emit custom metrics. So that these kind of metrics can help you to identify issue that might be causing your event to be slow or stuck or not working properly. Right. So monitoring can get you ahead of the problems before they happen. And if you are new to monitoring, start with small set of key metrics. And as you learn more about your system, you can add and refine your monitoring system. And when you're alerting on the metrics, be really careful and avoid the bad bad practices I mentioned earlier. And it's also very important to monitor your OS level metrics as well. Right, thanks for listening.